Today we will learn about exponents. Now, we've learned about squares and square roots, right? So, for example, if I have 10 to the power of 2 or 10 squared, this can be read as 10 squared. That means 10 times 10, right? It does not mean 10 times 2. So remember, this small number here on the top tells you how many times this number is being multiplied. Okay, so this 10 is being multiplied 2 times, so the answer would be 100, not 20. Okay, and you can actually extend this for any other numbers. And you can multiply more than 2 of the same numbers. So remember, when we first learned multiplication, we learned multiplication to simplify addition, right? When we're adding 3 plus 3 plus 3 plus 3, you can add this like that is 6, 6 plus 3 is 9, 9 plus 3 is 12, so the answer should be 12. You can do it like that. Or if you're adding the same number, you can use multiplication. You can say that's the same thing as 3 times 4. You're adding 3 4 times. Right, 1, 2, 3, 4. You're adding 3 4 times. So you can just memorize the multiplication table and say that that actually equals 12. And I think right now a lot of you are just using multiplication like this. You don't actually add this number this many times to get the answer, right? You've memorized the multiplication table, so you can just automatically get the answer by multiplication. Okay, and we can actually do the same thing with exponents. Okay, you can't, there's no really a exponent table, but you can simplify expressions. So if we have 3 times 3 times 3 times 3 instead of plus, right? If we have that, you can rewrite this using exponents. Okay, so that can be rewritten as 3 to the power of 4. Okay, this little 4 means how many times is 3 being multiplied. Just like this 4 here told us how many times 3 was being added, this 4 is telling us how many times 3 is being multiplied. And let's actually go over some of the terminology associated with exponents. This number right here is actually called exponent. The exponent tells us how many times the number down here, this number actually is called the base. So the exponent tells us how many times the base is being multiplied. Okay, so this tells us that the base 3 is being multiplied 4 times. Notice that the exponent itself is not being multiplied. We don't multiply this by 4. Okay, this just tells us how many times the base is being multiplied. Okay, so in this case, it's being multiplied 1, 2, 3, 4 times. And we can actually evaluate this. We can do that as 9. 3 times 3 is 9. This is also 9. 3 times 3 is 9. So 9 times 9 is 81. So the answer would be 81. Okay, so these are the parts of an exponential expression. So this little number right here is called the exponent. And the big number down here is called the base. And also, there are different ways to read exponents. So let me write a few exponential expressions here. Okay, first of all, what number is, let's consider this first one here. What number is the base or which number is the base and which number is the exponent? And if you said that 3 is the base, so base is 3 and exponent, let's write EX, exponent is 2, you're absolutely right. Okay, this small number is the exponent, and the big number down here is the base. And what does that actually equal? 3 squared. Or 3 times, that is 3 times 3, right? Remember we've learned squaring numbers. 3 times 3, so that is going to equal 9. And how you read that, we actually went over that. When the exponent is 2, when this part is 2, exponent equals 2, then you read this as the base 3 squared. Okay, you use the word squared. And it also works for other numbers. If you had a 4 here as the base, that would be 4 squared. If you had a 10 here, that would be 10 squared. Okay, so this is how you read when the exponent is 2. When the exponent is 3, like in this case, the exponent is 3, you actually read that as, you say the base first, 3, and then cubed. So the case when exponent is 2 and when exponent is 3, they have special ways of being read. So the base, if this was 4 with the third power, that would be 4 cubed. Okay, so you would put the base where the blue part is here. And you read, when the exponent is 3, you read it as cubed. And for all of these cases, so when the exponent is bigger than 3, they all have the same way of being read. Actually, well, you'll have to write or say the correct number of the exponent, but the concept is the same. So you say the base first, 3, to the 4th power. Okay, so this part would be the exponent part. So if the exponent is a 4, you'll say 4th. In this case, it's a 5, so in that case, you'll say 5th. Or in this case, you'll say 6th. Right? You get the picture, right? And if its exponent is a 10, then you'll say 10th power or 20th power. Okay, so this is how you can read. You can also read, for the case when it's 3, you can also say 3, instead of saying cubed, you can say to the 3rd power. But cubed is much shorter, so people usually just say cubed instead of to the 3rd power. However, for 2, you almost always say squared. I haven't heard anyone say like 3 to the 2nd power. Okay, I think saying squared is much more common. Okay, or there's another way to read exponents. You can also read it 3, so the base would go here again. 3 to the power of, and then you'll write the exponent here. So for the case when the exponent is 4, you'll say 4. When it's 5, you'll say 5, or you'll say 6. So these are 2 different ways to read exponents. You can say 3 to the 4th power, like this, or you can say 3 to the power of 4. If you are more comfortable reading numbers like this, then you can use this method. Or if you're okay with reading numbers like this, you can use this method. Either way is fine. So now let's try and find, or try to evaluate a few of exponential expressions. So let's say we have 4 with a little 5 here. First of all, how do you read this? Oh, before we go over the reading, what is the base and what is the exponent? Base and exponent. I don't think this would be really hard. But the base is this big number down here, so the base would be 4. Exponent would be the small number up there. Exponent would be 5. Okay. Now, how do you read this expression? And there are 2 ways to read this expression. You can say 4 to the 5th power, or you can say 4 to the power of 5. Okay, so the base would go here and the exponent would go here. Okay, either of those are fine. And how do you evaluate this? Okay, so that is the same as 4 times 4 times 4 times 4 times 4. Right? So let's pair these up. Let's multiply these together. So 4 times 4 is 16. 4 times 4 is 16. So we can simplify it to 16 times 16 times 4. And if you multiply that out, if you multiply 16 times 16 actually, you'll get 256 times 4. And if you multiply that out, you'll get 1024. Okay, so this would be the answer for this expression right here. Okay, another case when we use exponents is with prime factors. Prime factors. And if you don't remember prime factors, given a number like 24, we are dividing up this number into so that it becomes a product of prime numbers. Right? So which 2 numbers multiply to 24? You can say 2 and 12. Okay, and then 2 is already prime, so you can't simplify that. That's 2 and 6. 2 is prime here, and that is 2 and 3. So if you want to express this as a prime factor, that becomes 2 times 2 times 2 times 3, right? We have the prime numbers here. But you can simplify this expression with exponent. We have 1, 2, 3 2's that are being multiplied. So you can write this as 2 cubed times 3. Like this. Okay, so you can use exponents to express prime factors like this. And one last thing I want to go over is exponent of fractions. So let's say I have 2/3. Let's say I'm raising this fraction to a power. So this can be read as, or in this case, the base would be 2/3. Right? That would be the base. This would be the exponent. And you can read this as 2/3 to the power 5 or 2/3 to the 5th power. You can read it the same way as you would a whole number. But how do you evaluate this? Well, this is the same thing as 2/3 times 2/3 times 2/3 times 2/3 times 2/3. I remember the case when we had a square here before, or in a previous lesson. You're using the same method. Okay, in this case it's a 5. So now that is, you're multiplying 2 5 times in the numerator. So that becomes 2 to the 5th power. And you're multiplying 3 5 times in the denominator. 3 to the 5th power. So now that becomes 2 to the 5th power is, that is 4 right there. That is another 4. And 4 times 4 is 16. Times 2 is 32. And then you can do the same thing to the bottom here. That is 9. 9 times 9 is 81. Times 3, 243. Okay, so you can find exponents of fractions like this. And again, another way to do this is just simply distribute the exponent to both the numerator and the denominator. And you'll get this, and evaluate them separately. Okay, so that's how you can find exponent of a fraction.